Okay, yeah, my name is Liz Fiacco. I'm be talking about Lab Assistant, a game that me and some of my friends, my brother made, and how it's kind of representative of machine learning algorithms as an emotional partnership, and kind of what we went about and some of the techniques we used. So a little bit background on me. I'm a professional game designer, not a machine learning person. So I work on commercial games, particularly character and story-driven games. So I'm working at Ember Lab right now on Kena Bridge of Spirits. I worked at Naughty Dog. I worked at Obsidian, places known for their kind of high fidelity character work. And my brother, James Fiacco, he's working on his PhD in natural language processing at Carnegie Mellon. So basically, we wanted to make a project that sort of combined our disciplines that used this sort of natural language processing work and our character-driven game development work, and make something cool. So we got together a handful of people just for a weekend. We got through most of the game in just a couple days, and then we took about 3 more months to sort of like clean everything up, wrap everything up, and ended up releasing it on itch.io. The game itself is based on a paper that we found, and they demoed their algorithm with this kind of block sort of like game in browser game, where you would give it written instructions and then you would make corrections and it would have to reach its goal in just a short number of moves. So it was learning really fast. It started with no vocabulary, and we were really, really excited about this. And part of that could help because we kind of knew how artificial intelligence worked, so we could see kind of behind the scenes of like, oh wow, it's like actually working. We felt a lot of pride when it finally got something correct, or when it started speeding up its guesses. And we were like sharing it with a bunch of people, and we found it was kind of tricky to share it with people who didn't know anything about machine learning at all. It sort of relied on our outside knowledge to sort of like understand why it was exciting. And it took us, even us, kind of like knew what it was supposed to do, a little while to understand like what the UI meant and like how to actually make it work and the best way to strategize. So I started raising some questions between us of like, how do we make this accessible to people who don't know anything about machine learning, and make them feel the way we did about training an algorithm. So Lab Assistant was born. This is kind of a screenshot from it. The slime is, that's our character. So it's sort of the physical manifestation of the AI that you're training. Up in the corner is a formula. So that's like the goal that you're trying to reach. The chemistry table, that's like what's currently available to you. So you're trying to make that reach your goal. And then this input is really simple. It's just text inputs. You can write whatever you want. The idea is you give the slime commands, and then it does its best job, and you correct it whether or not it got it correct or not, whether it needs to try again or not. So basically, every time you give it a new command, it generates a list of guesses. So that can be this like computationally big process. But then as you kind of go through the guesses, correcting whether it got it right or wrong, it's actually pretty quick. It's just going through the whole list. So you guys here know how to make algorithms. You can make the coolest algorithms of all time, but what we were concerned with was how do we then translate the cool algorithms, this technology that we're using, into the actual experience of interacting with a character. Like, how can we give this personality? How can we make the players like think that it's thinking, and understand their impact that they're having on it? So here's an example from Unity. They've got these two sort of paddles that are trained on machine learning to keep the ball up in the air. So it's pretty cool. It's really awesome tech in order to like get this kind of thing working. The fact they can bounce it back and forth and everything, and the how basically how confident they are that they can keep the ball going is being represented by these green bars kind of up overhead. So as people who are familiar with machine learning algorithms, we can look at this and be like, oh, cool. Okay, so it like bounces it and it like really thinks it's going to get it. And then as it kind of like goes in a different direction, then it like loses confidence. Okay, we can kind of track it. You know, it drops the ball. It's like confidence plummets, right? So as like scientists and people familiar with this technology, we can read what's happening. But if we want to make this accessible, we need to use language that kind of the lay person can understand. So I did a quick animation over top of this of some eyeballs. We all know how to read eyeballs, expressions, emotions. So this is purely aesthetic. You can imagine that that number that drives that that bar filling up or depleting could be hooked up instead to an array of expressions or animations to be readable to kind of the layperson as they set this kind of thing up. So that was kind of the idea behind Lab Assistant, and we kind of took this as far as we could. So yeah, the idea here is now we basically tried to use the whole toolbox of techniques that I use in video game design to sort of obscure the sort of weird behaviors of machine learning, and like kind of rather than trying to like improve the algorithm's capabilities, we tried to find ways that we could sort of excuse any shortcomings it had or improve the back and forth between the human player and the algorithm itself. So video games use AI characters, like state script sort of AI characters. They've been using that kind of thing for years, and we have like a lot of techniques in order to sort of hide the fact that they're not actually that smart. So one of the big ones is if they say what they're thinking, like if they announce like, oh, go hide behind that corner, and then they do it, people tend to infer that they're smart. Oh, they made a plan and then they executed the plan, where it's really just like, okay, as soon as they decide they're going to go behind the corner, you kick off like a line that tells them that's what their plan is, and then they do it. On the back end, it's not that much smarter, but on the front end, it appears a lot smarter. So we kind of use that same sort of logic here. You can use data from the AI itself. So like, for instance, that confidence scale to inform the animation states. So you could set up expressions or something like that. And you can do that for as much as you basically time and budget allows. There's all sorts of data that you can get from machine learning that you can then translate into expressive emotional states. And then basically, if you see the character thinking as well, you're going to think that they're thinking. So we tried to use that. We made sure to validate our data for player usability. So basically, even in games without machine learning, you kind of like cheat the dice a little bit behind the scenes to make sure that they're going to have like a really fun experience. One technique that we used to use is what's called a trapdoor. So if we are detecting that a player has died multiple times in a row in the same kind of combat encounter, then like behind the scenes, we give them like a little extra ammo or a little extra health, and eventually they'll be able to like overcome that combat. And it's something that's invisible to them, but it definitely helps like favor them. So we approached this game as well with like this player favoring mentality rather than giving them necessarily the super hard facts of what this machine learning stuff was doing. And then finally, we want to make sure that we use player-oriented language and language that fits the sorry, I think my headphones went out of batteries, but we're good. But yeah, we're good. Cool. But yeah, we wanted to make sure that we use accessible language, so describing stuff as the player sees it, or how it makes sense in the world, as opposed to describing like the underlying system. For instance, like in video games, like you might not necessarily have something represented as like, oh, this is giving you more health. You know, every game is going to like deal with that a little bit differently. Like, oh, it's food or something, and that gives me more health, or like different theming. We wanted to make sure that we did that as well, so the player could make sense of what's going on without needing to know how it works behind the scenes. So that was kind of some of our design philosophies. And then we kind of backed that up with just appealing art and sound, which I know can be a difficult thing. But I do want to like emphasize that we did this in a very, very short amount of time. So it wasn't so much like the quantity of assets or sound or anything like that, but it was just about doing something simple and expressive. So the key thing here was whether or not it communicates the emotion that we want. So making just really clear poses, really, really obvious emotions, like this drawing I did here, like everything about it. We like added blushes, added hearts, like tried to make it as obvious as possible that that the slime was like delighted right now. Another one would be making sure that we believe it's always the same character. So trying to like maintain like, okay, we can draw this slime in like a lot of different ways, but it's clear that it's not like swapping out like different avatars or things like that. So we can like build a relationship with this like one character. We wanted to reduce like how annoying any art and sound could get, because we do know that like the gameplay itself can be repetitive. So the animations that we knew that we were going to be seeing over and over again, we wanted to make sure they were very short. So we did a very, very short cycle for swapping out the beakers, because that's what you see the most. The idol that we had, we tried to break that up with like just like one little fidget every once in a while. So anything that looked like it was repeating for a very, very long time as well, we wanted to make sure that we had a kind of a random interval where it would like alternate like what it would look like. So I think for us, we probably only had like 2 or 3 frames for the idle. So it would just play those on a loop for like seconds at a time. And then every once in a while, randomly, we had like 2 frames where it would kind of like sit up a little bit higher and then blink twice and then go back down into its idle. So even though it could like sit there for a very long time, it looked like it had some life to it. And then we also stuck to really simple character design. So this would have been a lot harder if we were trying to do like a full humanoid character, even an animal character. The more structure, the more detail that you put onto a character, the less appealing sometimes it can be, and it's more expensive to do. So we went as simple as we possibly could. And really just tried to focus on like, okay, how, like, it's just pure expression and that is it. One key sort of brain space that we were in as we started playtesting the game is we were kind of like finding problems and trying to evaluate how we were going to fix them. And every time we try to approach it as evaluating this game as what it's like to be interacting with a character and not interacting with an AI. So we weren't approaching it from the mindset of like, okay, the computer is not working. Obviously, there were bugs and stuff we had to like hash out, but we also looked at it was like, okay, everything could be working technically, but does this feel right for the character? Does it feel like we're building a relationship? Does it feel like it's paying attention to me? Does it feel mechanical or does it feel alive? So an example of that would be, okay, if it gets this puzzle wrong in a row a lot, so it just keeps like failing and failing and failing, and it feels like you're telling it no, 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 no over again. Instead of saying like, oh, the algorithm needs to get better at guessing, we're thinking it feels weird to have a character just okay with being told no, 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 no over again. Like maybe instead of getting better at guessing, we have it react to you. So there's a chance that it'll like kind of like get a little angry whenever you tell it no. So then it feels like, okay, it like had a reaction to me and you're like, oh, I'm sorry. And then you try something else and you take another approach. And it worked pretty well. Just adding that sort of detail. So I'm going to go through like a couple of example problems that we ran into setting something like this up that aren't normally problems in video games. So this is specifically like, oh, sure. Okay, yeah. So yeah, one example would be that it would sort of guess the same thing over and over again. So we made a script that basically just auto rejected duplicates, basically, and that way it didn't look so stupid. We covered up like a really, really long load time just with like a thinking animation. So even though basically instead of looking like the game hung, it would look like it's like actually thinking. So people were like, okay, it's busy. And then, yeah, this is the one I kind of mentioned already, where like if you tell it no a lot, then it kind of like gets a little angry at you, and people like could understand that it was reacting to you. So yeah, people can actually get good at this. They can get better with consistency, patience, and brevity. And so we think that it's actually going to be like pretty rewarding gameplay as we like expand this kind of idea. So we've expanded it in a Unity plugin where we've integrated Dynet. So we have a lab rat race as a demo available with that. And then we're working right now on a game called My Dragon from Hell, where you train a pet dragon. So that's in development right now using this same technology. There's a lot of stuff to keep working on, keep improving, mostly regarding pushing technical limitations, and then also just expanding our reach to both reach game developers using this technology, and then also machine learning scientists to see if we can inject more character and humans into the sort of loop of building these algorithms. Cool. This is how you can play it. It's free to play. Our plugin, if you want to check that out, and then you can find me on Twitter and through email. We're done.
Cool. Sorry for cutting you short there.
No worries.
It's awesome, and I could listen to you talk about this all day, but we gotta get moving. So before I ask if anybody else in the session has questions, I want to know like what. Like this is kind of just like a personal question. Like what kind of AI tools do you want for making games? Like kind of like an extension of this game or the next game that you're like building, and you wish you had this tool. Like what kind of tool would you want?
So in terms of, I mean, I can imagine a lot of ways to use AI in terms of like authoring content for video games, but at the end of the day, that's not like a new kind of game. what we're looking at here is involving the player in the game, or involving the player and the AI kind of together in a game loop, which kind of I think opens up the potential for like new game genres. So in terms of tools, I'd probably say we do have to work on like the pipelines for pre-training some of these algorithms, because there's like kind of a baseline that is helpful for like jumping in. Um, uh, it's interesting. I mean, like part of it is like we built the tool that we wanted. Like we built the Unity plugin that made it available, so we can run machine learning at runtime. So I think like the more we experiment with that, the more we're going to want to like make improvements to it and add stuff to it.
Cool. So I'm
Yeah.
wondering if anybody in the Zoom room right now has any questions, like Max or Rachel or Yanzhao. Feel free to talk.
I'm kind of curious. How do you think the way that you're developing character differs from the current expectations that people have for machine learning and AI interactions?
I think it depends on who you talk to, like what their expectations are. I think in terms of like the sort of general public consumer end, I think people tend to think of machine learning to this day as like kind of like HAL 6000 or whatever it is from 2001: A Space Odyssey, or these kind of like omnipresent, always has the answer um, masterminds. And I think this kind of introduces this idea that like machine learning is actually about a blank slate that you can customize to fit your needs and your context. So I'm hoping that is one way that people can sort of rethink machine learning. And then in terms of making them endearing characters, um, part of my hope with that is to also think to change the way that some people think about machine learning as this sort of like massive data collection. Um, this kind of came up in an earlier talk, but like this neutral thing that just kind of aggregates lots of data, and it's actually more like like a pet or a child, and it learns what you give it. So if it kind of has a face and a character, then I'm hoping that people understand that they have like this obligation of like stewardship or nurturing to like make sure that it is the best that it can be. Does that answer your question?
Yes, thank you.
Cool.
Okay, that was awesome. Well, thank you so much.